Welcome back. In this tutorial, we are going to cover Advanced Ortho number 5. For your reference, I do not assign Advanced Orthos 1 through 4, so we're just going to start with number 5. So let's take a look at number 5 and let's ask our three basic questions. Does it have symmetry? Yes, it does. Symmetry is from left side to the right side. They're both the same. How could you describe this part / how many chunks could you tear it into? And I would say you could tear it into 4 different chunks. The 2 ribs that we have, the back piece, and the bottom piece. Which view best shows the shape? I would say all 3 views, because you see the angle in the side view for the rib, the angle cut here in the front view, and the angle of this pointed piece in the top view. So where are we going to start with this part? Well, to me, it really doesn't make any sense to draw the ribs in first. So that pretty much leaves us with either the back or the top. So let's go ahead and do this top section, or this bottom piece, whatever you want to call it, this pointed piece. So what we're going to do is we're going to go back to Inventor, and we're going to sketch on top, ensuring that the word top reads correctly. Since we have symmetry, we want to project all 3 planes. And I'm going to draw a line, and I believe this entire part is 5 inches wide, but we can double check that real quick. And it is. So I'm going to put a symmetric constraint. Remember, symmetric, we say this point and this are symmetric about this. And I'm going to put another point down here, making sure that it lines up with my vertical projected geometry of my Z. And I'm going to dimension from here to here as 2.12. And that is my overall depth. And then I need a line at 1.37. So what I'm going to do is draw a line here, 1.37, down to my point, and then I'm going to do another line, 1.37, and down to my point. And now I can extrude this. I believe the thickness of this is 0.5. We'll double check that when we go back to the PDF. And that is correct, 0.5. All right, good. So next step, I would say, is we'll draw the back in. And there's a couple different ways we could do this. We could draw this on top of this as a rectangle and then put in 2 chamfers. We could also just draw this in. So let's just go ahead and do it the chamfer method. I don't really care which way that you want to do it. Either way is fine with me, but let's just go ahead and do it this way. So we'll throw in a 2-point rectangle, 5 by 0.5, and then we need to extrude that up 2.5. And the 2.5 came from this 3 minus 0.5. Next step is to add a 1.12 inch chamfer. Chamfer 1.12. And since the distance, or the angle I mean, is a 45, we can just pick both of those and hit OK. Now, this is where things get a little tricky. This is probably one of the more difficult of this set of 4. What do we know about this rib piece? So let's start off with the numbers that we know. We know that this triangle here is 0.5 from this line right here. We also know that it is 0.5 thick. What we're going to assume is that this line lines up with this point right here, height-wise. So this length here and this length here are the same. We also know that this line starts at the corner and comes until it hits this angled line right here. This is key. This is the hard part. So if I were to sketch, let's make a new plane, offset in negative 0.5. And remember, if you accidentally type in 0.5 and hit enter, you would just double click the button and change your distance. So we'll sketch on this, and we're going to project this point and this line. Now, if I draw a line from here down over to here, the question is, where does that line stop? So if I look at this, clearly I'm extended out too far, but if I try to drag this back, it's not clicking on this line. If I project this line, it's irrelevant because I already projected it here. Let's try this. Project this and then bring this back. See, it won't snap into that. So the question is, how do we do this? And the answer is to use a helper sketch. So what I'm going to do is, and I haven't covered this yet, so this is new, I'm going to take this end of part and drag it above sketch 3. Think of end of part kind of like a time machine, right? Our model tree is chronologically ordered, so where did sketch 3 go? Well, sketch 3 hasn't existed yet. It doesn't exist yet because I took my end of part and dragged it above there. So what I am going to do is I'm going to sketch on top of this face, and it's important that I have this work plane here first. Okay, so I'm going to sketch on here, and I'm going to project this work plane, and I'm also going to project this angled line, because what we really care about is the intersection of those two, and I'm going to put a point on here. And notice that that point looks like a plus sign, which is exactly what we want. Now what I'm going to do, we can see work plane 1, we can see sketch 4 actually happens before sketch 3. So I'm going to drag end of part down, and now I see sketch 3, and I can see it's kind of difficult. Let me change this to wireframe real quick. Let's go wireframe with visible edges only. So what that'll do is it'll kind of, it won't show the hidden lines that are inside, but it doesn't have any shading. So here we can see my point is still right here, which is what I want. So I'm going to edit sketch 3. I'm going to hit F5 to look at my previous view. And I'm going to project geometry this point right here. And now you can see, and it's kind of hard, but you can see that this little yellow line is sticking up. And so when I look at my right side view, I see that point right here. Now I'm going to put a coincident constraint between this point and that point. Now I can finish sketch, extrude that, 0.5. Let's try 0.5, flipped, and hit OK. Now I don't need this and I don't need this anymore. Right click, visibility. By the way, I held down Control to pick both of these at the same time and turn the viz off on those. Now, how do we get this over here? We're going to mirror it. Pick my feature out of my model tree. Remember, that's a good habit. I want to mirror about my YZ plane, just here. Okay. Now when I change this back to shaded with edges, we can see that my part is done. Now the neat thing about this is, let's say I go back to extrusion 1, and I change my 2.12 dimension to, let's say, 3 inches. This is going to automatically adjust because it's this and work plane 1's intersection. So regardless of what angle this is, where this line is, it's automatically going to go to there. Now let's say I take work plane 1 and I change this to negative 0.75. It's going to push it in, and watch, it still stops at that intersection, and the other side is the same as well. So let's go ahead and undo that. So this part, again, a little tricky. It's a little more complicated, but it's good practice to kind of take apart and pull it into its base pieces and kind of reconstruct it back into the computer. Thanks, and we'll see you for the next one.